I should start recording. First thing I want you to do, please, is cross out range and change this to slant asymptote. We haven't talked about range. But as we go through, guys, you need to remind yourself, when we talk about zeros, that's the X-intercept, and I want it as an ordered pair, X, Y. When we talk about vertical asymptotes, that should be X equals. When we talk about horizontal asymptotes, that should be Y equals. Y-intercepts, again, should be an ordered pair. And my domain should be in interval notation. Interval notation. All right, your slant asymptote should be in Y equals mx plus b. If you guys don't have that stuff, you're going to get points off. So it is important that you pay attention to what I'm saying and that you're careful when you work. All right, so let's go through everything we have to do. In order to find, I always tell you guys do domain first. In order to find the domain, where do we look? What do we do? Domain. Denominator not equal to 0. So my domain, I'm going to say x plus 1 cannot be 0. So I'm going to subtract 1 from both sides. So I say x cannot be negative 1. Agree or disagree? Agree. Okay, so I would say for my domain, how would I say it can be any single number in the world except for negative 1? Negative infinity to negative 1. Union negative 1 to positive infinity. Good. I get you, believe it. All right, next thing we're going to talk about is our vertical asymptote. Vertical asymptotes, guys, go hand in hand with our domain. So I have a vertical asymptote where? At x equals negative 1. People at home, can you hear me?
Yes.
Okay, we're just being quiet today. Okay, just making sure you didn't go anywhere. All right, if I talk about horizontal asymptotes. Horizontal asymptotes. Horizontal asymptote, I compare the numerator to the denominator, degrees. So it's 2 and 1. 2 is greater than 1. What's my horizontal asymptote? What is it?
0?
Not 0.
There's not one.
There's not one. We would say none. We don't have one. That's okay.
It'd be 0 if the denominator was greater, right?
Correct. So for horizontal asymptotes, you would write none. All right, X-intercepts. How do we find X-intercepts? Or zeros? Numerator equal to 0. So x squared plus 4x minus 5 equals 0. I'm going to factor this. What times what gives me a negative 5 when I multiply and a positive 4 when I add? X plus 5, x minus 1. Okay, so I have intercepts at x equals negative 5 and at x equals 1. So I would write that as negative 5 comma 0. It was negative 5 and positive 1, right? And 1 comma 0. Everybody okay?
Yeah.
Okay.
So far.
Okay, good, good, good. So now I'm going to find my y-intercept. How do I find y-intercept? Plug 0 in for x. Perfect. F of 0. So when I plug in, I have 0 squared plus 4 times 0 minus 5 over 0 plus 1. Negative 5 over 1. So I have a intercept on the y-axis, and I would write that as 0 comma negative 5. How do we find holes? Factor.
Factor denominator.
Okay, so I'm going to factor. We already factored the numerator. It was x plus 5, x minus 1 over x plus 1, right? Do I have any holes here?
No.
Nope. So no holes. I'm going to say none. Whoops. Stop it. I know, I thought it was just like where I was sitting. I don't know, it's driving me crazy. Okay, and then the last thing is our slant asymptote. Remind me again how we find a slant asymptote. We got to have long division. But how can I just look and know, yes, I have a slant asymptote, or no, I don't? Yes, I can just look at it. If the numerator degree is higher than the denominator degree, then I know I have a slant asymptote. So we have to use long division. We have x plus 1 on the outside. And on the inside, I have x squared plus 4x minus 5. Now we have to check and make sure there's no holes, no gaps, nothing like that, right? Everything's okay?
Yep.
Okay, thank you. Thank you, thank you, thank you. So now I'm going to long divide. X into x squared goes x times. So I have x times x is, I wrote this in a bad spot. I'll write it down here. X times x is x squared. X times 1 is plus 1x. Distribute my negative. So I'm left with 3x. Everybody see that 3? 3x minus 5. So now I say x into 3x. X goes into 3x how many times?
3 times.
So plus 3. Do I have to go any further?
Nope.
No. If you guys want to continue it, that's fine, but the remainder does not matter. So I would say I have a slant asymptote at, how would I write it?
Y equals x plus 3.
Perfect. Y equals x plus 3. If you guys don't write the y equals, I'm taking points off. It's very important that you guys see that. So now we're ready to graph, okay? So I'm going to graph my intercepts. No, I'll do my asymptotes first. We'll do that first. Hold on, let me make my pencil a little thicker. All right, so I have a vertical asymptote at x equals -1. Your graph needs to be neatly organized, guys. If it's all over the place and a mess, I'm not even going to bother grading it. You have to be nice and neat. I have a horizontal asymptote, or no? No, no horizontal asymptote. Do I have a slant asymptote? Yes, my slant asymptote is at the line y equals x plus 3. So guys, all you do is go up to the intercept of 3. Your slope is 1, so it's just going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1, right? A slant asymptote is a slanted line. Should look something like this. Real close to this, not something like. Now let's do our intercepts. I have x-intercepts at -5, 0, and 1, 0. So 1, 2, 3, 4, -5, 0. And then I have one at 1, 0. Good. My y-intercept was where? 0, -5. 1, 2, 3, 4, 5. Now you guys can kind of see where your boomerangs are going to exist. But we want additional points. We want to make sure. So pick a point to the right of your vertical asymptote and to the left of your vertical asymptote. My vertical asymptote is at x equals -1. So pick a point to the left of your vertical asymptote.
-2.
Okay, so if I plug in -2, f of -2, let's see what happens here. Right, so I have -2 squared plus 4 times -2 minus 5 over -2 plus 1. You guys agree? Yes or no?
Yes.
Okay. So I have -2 squared is 4 minus what?
8.
8
minus 5.
minus 5 over -1. What's 4 minus 8?
-4.
Minus 5.
-9.
So -9 over -1. So when I plug in -2, the point I get out is 9. So if I were to plot that point, Negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8. It's up here somewhere, right? So where is my boomerang going to exist? Is it going to be to the top portion of the slanted line or the bottom portion of the slanted line? The top portion. It's going to be right here. It's going to hug my asymptotes and be right here. You can tell where it's going to exist. Now, I think you guys can see where the other one's going to exist, but let's just pick an additional point. Pick something to the right of your intercept at 1. Pick something to the right.
0.
Okay, you can do 0 if you want. If I plug in 0, f of 0, so I have 0 squared plus 4 times 0 minus 5 over 0 plus 1, right? Well, that is going to end up being negative 5 over 1, right? We already found that one. So let's pick another one. Just to make sure. I just want you guys to make sure. Okay, 2. That's fine. So f of 2. 2 squared. Is it plus or minus? Plus 4 times 2? Minus 5? Over 2 plus 1? Did I fill that in right? My signs are right. So 2 squared is 4. I have 4 plus 8 minus 5 over 3. 4 plus 8 you said was 12 minus 5 is 7 over 3. So 7 over 3. So when I get a 2, I get 7 over 3. That's a little more than 2, right? So it's like maybe there-ish. Do you guys see where your other boomerang is going to exist? It's going to be right here. Like that. So that is what our picture looks like. I know it's kind of hard to see right now because the graph is so dark. But we just took, guys, 12 minutes to do all that work right there. What I want you guys right now, I'm going to give you guys like 10 minutes. I want you to do number 6. We'll go over it. If you just try. I'm going to go over the whole thing. But please just try. Without asking me any questions, just try. I mean, I'm here if you get completely stuck on something, but I will go over it in just a minute. But just try for me, please. So if I'm going to find the domain for this function, I look and I set the denominator not equal to 0, correct? Is that how we do that? Okay, so I'm going to say 3x squared minus 15x cannot be 0. Correct? Yes or no? Okay, so if I factor this, guys,
Right.
I'm going to factor and I get 3x. I'm going to pull that out. And I'm left with what? X minus 5? Cannot be 0.
Yeah.
So I have 3x cannot be 0 and x minus 5 cannot be 0. So I have my domain restriction is 0 and positive 5. Domain cannot be either one of those numbers. Does everyone agree?
Yeah.
So for my domain, the way that I would say that is negative infinity to 0, union 0 to 5, union 5 to infinity. Agree? Okay,
Yeah.
so now we're going to look and we're going to say, okay, well, what's my vertical asymptote? Because your vertical asymptote goes hand in hand with your domain. So I have vertical asymptotes at x equals 0 and x equals 5. Yes?
Yes.
Okay, horizontal asymptote. Horizontal asymptote is where we compare the numerator and the denominator degrees. So the numerator degree is 2, the denominator is 2. They are equal to each other. When they are equal to each other, we say that the horizontal asymptote is where the leading coefficient of the numerator is over the leading coefficient of the denominator. So I have a horizontal asymptote at y equals 1/3. Everybody okay with that?
Yes.
Okay. Do I have a slant asymptote?
No.
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 If I tried to divide x squared into 3x squared, I would just get 3. So my slant asymptote is none. You need to write none. Okay, zeros. How do I find the zeros again? The X-intercepts?
Zero.
Okay. Numerator to 0. So x squared minus 4 equals 0. X equals plus or minus 2, correct?
Yeah.
Okay. So I have zeros or X-intercepts at 2 comma 0 and at negative 2 comma 0. You could write it the other way. I don't know why I wrote the positive one first. All right, now let's go through finding our Y-intercepts, okay? This one might have thrown some of you a curveball, and that's okay. But if I have my Y-intercept, that's where I plug in 0 for all of my x's. So I have 0 squared minus 4 over 3 times 0 squared minus 15 times 0. This ends up being negative 4 over 0. If it was 0 over negative 4, your answer would be 0, correct?
Yeah.
But negative 4 divided by 0 is undefined. That means you don't have a y-intercept. Your answer here would be none. You don't have one. All that means is your graph does not cross the y-axis. That's it. Do I have any holes?
No.
When I factor the top, I have x plus 2, x minus 2. When I factor the bottom, I had 3x times x minus 5. Nothing cancels out, so no holes. All right, do I have anything else that I need to figure out? Let's go through. Let's go through and graph it. Okay, so I have my asymptotes are at 0 and 5, my vertical ones. So I'm going to go to 0 and 5. 1, 2, 3, 4, 5. If you guys have colored pencils or something and you'd like to use them tomorrow, you're more than welcome to. It'd make my life a lot easier. My horizontal asymptote is at y equals 1/3. Do I have to be super exact with this? No. But y equals 1/3 should be in between 0 and 1. Right? If you tell me y equals 1/3 is around 3, then I'm going to mark off because that's not the case, guys, right? Now let's plot our intercepts. I have intercepts at 2 and negative 2. So positive 2, 0, and negative 2, 0. Where was my y-intercept? I don't have one. Okay. All right, so we have kind of this picture is what we've created. Now we have to figure out where our boomerangs exist on the outside, and in the middle if I have a snake or if I have a parabola. So let's pick something. Pick any number you want to the left-hand side of our vertical asymptote. Some of you are going to say, I already know where it's going to be because where the intercept is, but let's just pick a different number just to check. Make sure we didn't do anything wrong. Pick a number to the left of the 0.
-1.
Okay, -1. If I plug in -1, f of -1. When I plug in -1, what do I get out? My function is -1 squared minus 4 over 3 times -1 squared minus 15 minus 1, or times -1, right? Okay, so I have 1 minus 4 is -3 over 3 plus 15.
18.
Right? Okay. So this becomes -1/6. It's not really about the -1/6, guys. I'm not super concerned that you know how to plot the point -1, -1/6. What you need to understand is when I go over to -1 right here, where is -1/6? Is it above the horizontal asymptote or is it below it?
Below.
It's below. So I know it's down here somewhere-ish there. So I know this first boomerang exists here. Whoops, too close. You want to get close to the asymptote, but don't touch it. Okay, let's do the other boomerang on the other side. Pick a number to the right of 5.
Does I have a question?
Yes, ma'am.
So when you're figuring out, what do you call what you just did? The answer, -1.
The additional
-6.
points.
Okay.
We call those the additional points. Or
When you're trying
figuring
to
out where the
figure out
boomerangs
how-
go.
Oh, were you talking? I didn't hear you.
No, I'm just saying, or you say figuring out where the boomerangs go. That you can say that too.
You're trying to figure out where the boomerangs go.
Perfect.
Does it have to be, you said, to the left and to the right of the vertical asymptotes? But does it have to be above, like, let's say there was a horizontal asymptote, but it be in between?
The horizontal just tells you, that's like your dividing line. When you pick something on the x-axis, when you pick one of the numbers to the left, your horizontal asymptote is your dividing line that says, okay, when I plug in this number on the x-axis, is the number that I get out above or below? And that's where it tells you the direction of your boomerang.
Okay, thank you.
So if we're going to pick 6, okay, I'll do this over here. We'll do f of 6. So it's 6 squared minus 4. And then 3 times 6 squared minus 15 times 6. Is that correct? My screen's not letting me go back and forth. Okay, so I have 36 minus 4 over 6 squared is 36. What's 36 times 3?
108.
Okay, so 108 minus 90. Okay, so 36 minus 4 is 32. 108 minus 90 is 18. I can simplify this by 2. I don't really have to, but if I can simplify this, this becomes 16 over 9. Okay, so when I pick 6, right here, I'm looking at 6. Is 16 over 9, is that above 1/3 or is it below 1/3?
Above.
It's above it, right? It's above it. Say here-ish, whatever. What you need to know is that is the general area that your boomerang should be. Let me draw, please. Sorry, I'm talking to explain everything. Now, in the middle, this is where we get a little like, ay, ay, ay. What are my 2 choices for what the middle is going to look like? It's either going to be a parabola or a snake. Okay, so you're going to have to pick a couple points in here. I would not pick something right next to each other. I'd maybe look at this and I'd say, okay, I'll pick something to the left of the intercept and to the right. Because if I do that, I'll get some semblance of a picture. I might get a point here and a point here. If I got 2 points like that on the same side and when I connected them, what shape would it make?
Parabola.
A parabola. I might plug in something to the left and something to the... So what would that shape be?
A snake.
A snake. Okay, so that's what we're looking for is the general direction. So pick something in between 0 and 2. Try 1. When I plug in 1, I have 1 squared minus 4 over 3 times 1 squared minus 15 times 1. So this becomes 1 minus 4 is negative 3 over 18, right? Did I do that right?
Or no, it's negative 12 minus 15.
Yeah, you're right. I'm looking at it, I'm like, wait a second. So it's 3 minus 15, which gives me negative 12.
Next 12.
So when I plug in 1, I get out 1/4, okay? When I do that, look, if I plug in 1, I get 1/4. It's like there-ish. It's not on the horizontal asymptote. I know that. I don't have a lot of room, so just go with it, all right? It's just below it. I can't write that teeny tiny. But now pick something to the right of your intercept.
3.
Okay, 3. We generally would use the y-axis as our division line, but since the y is our asymptote, we'll just pick 3. All right, so when I plug in 3, f of 3. And this, I uploaded the answer key of this a lot prettier. It's already on modules. So I have 3 squared minus 4 over 3 times 3 squared minus 3 times 15. Correct? Okay, so 9 minus 4 over 9 times 3 is 27. What's 3 times 15, guys?
Negative 45.
Okay, 45. So I come out with 5 over negative, what's 45 minus 27?
18.
Okay. Now again, when I plugged in 3, I got negative 5 over 18. Is that going to be above the horizontal asymptote or below it? It's going to be below, like that. So when I connect these two dots, this is the shape that it's going to create. If it was going to be a parabola, they would be like kind of next to each other, but it would be a shape like this. Now, I got real close, guys. And if you're still not sure, some of you are going to say, well, I'm still not sure if it's going to be a parabola or not. Then check some more points if you're not sure. But look how I drew the snake in the middle in comparison to the y-axis. Does my snake touch the y-axis? No. Should it touch the y-axis? No, because when we found out our intercepts, we found out that there was no y-intercept. So we're going to be picky with stuff like that. I'm not going to be picky that you didn't get it just perfectly at -5/18. I'm going to be picky in the fact that if there's not an intercept, it shouldn't cross, something like that. But if you're sitting here and you're still like, I still don't know what shape it would make, then plug in more points. Make yourself a T-chart and plug in -2, see what your answer is. Plug in -1, see what your answer is. Plug in 1, see what your answer is. Find 20 additional points if you have the time, just to make sure that your picture looks like it should. Okay. Okay, as we look at this last one, number 5, I'm going to scoot over here so I can do some work. I think the easiest way for you guys to attack these problems that have factoring and stuff involved where you might have holes is to factor from the beginning. Okay, maybe this will help some of you. I don't know. I'm not sure. I'm just trying to present another way that I can show you. But if I factor this from the beginning, all right, if I factor the numerator and I factor the denominator, I have x squared plus 5x plus 6. What times what will give me a 6 when I multiply, but a positive 5 when I add? That would be x plus 2 and x plus 3. All right, and then on the bottom, this would factor to x plus 3 and x minus 3. If you guys want to do this on every problem, you can. You can just factor it out. You can still find everything else by plugging in zeros and all that into the factored form. But this might be helpful for you when you have a hole. Because if you notice here, x plus 3 repeats. So there is our hole. I have a hole at x plus 3 equals 0. So we're going to say we have a hole at -3. Once you guys cross off and recognize that you have that hole, you can now just find everything else based upon what's left over. Don't worry about going back to the originals. That might help some of us this way. We can still find the intercepts and all that stuff, because instead of, before I showed you guys to put it in and then we would go back and we would cross out, and that's how Miss Carver was doing it. I think that's how she did on the review too. If you want to just go ahead and factor from the very beginning every single problem, then you can just go through, cross out the hole, identify where it is, and now just do everything based on this function. So if you were going to find the domain, you would say set the denominator not equal to 0, so it'd be x minus 3 cannot be 0. So your domain is every number in the world except for 3. So we would write that our domain is -infinity to +3 union +3 to infinity. Domain goes hand in hand with our vertical asymptote. So you'd have a vertical asymptote at x equals 3. If you didn't factor first and get rid of the hole, you would have gotten plus minus 3 and all that stuff, but then you would have had to go back and take it out. So it might just be easier to look at it that way. Just when you attack every one of these problems, factor first, cancel out the hole, identify where it is, cancel it out, then proceed, and then it might be easier for you guys to see. As far as all of our other stuff, like I said, you can still find everything else using the factored form. So now let's look for our horizontal asymptote. Well, our horizontal asymptote will compare degrees. If I compare the numerator degree to the denominator degree, in our original, it's 2/2. In the factored form, it's 1/1. Same thing, you'd still get the same answer, that you'd have a horizontal asymptote at y equals 1. So we're going to say our horizontal asymptote is at y equals 1. The next thing that we can look at, we can talk about, like we already identified the hole. There was a hole at -3. All right, our zeros, or our x-intercepts, are going to occur where the numerator is equal to 0. So we would say x plus 2 equals 0. So I have an x-intercept at -2. And again, we're going to write that as an ordered pair. negative 2, 0. If you did this with the original form, you would have gotten a negative 2, 0, and negative 3, 0. And then you see that there's a hole there, so you'd have to go back and erase it. So we'll just leave it like that. That's good. Our y-intercept is where we plug in 0 for our x's. So if I want to find my y-intercept in my factored form, I would get 0 plus 2 over 0 minus 3. So I get negative 2/3. If we plug it into our original, we would have gotten negative 6 over 9, which reduces to negative 2/3. So you have a y-intercept at y equals negative 2/3. Our slant asymptote, there is none because our degrees are the same. So now if we go to plot our points and to draw our graph, we go based upon what we have. Again, get rid of the hole first, and then you don't even have to worry about it. You don't have to worry about where it is in the graph or anything. So I have a y equals 1. That is my horizontal asymptote. I have a vertical asymptote at x equals 3. So here at 3. I have a y-intercept at negative 2/3, so I know it's here-ish. My x-intercept is at negative 2, 0, so it's here. So right now, you're seeing where your boomerang exists in the bottom here. It's going to be right here. And then we're going to pick a point to the right of our vertical asymptote. So let's pick, I don't know, 4. We can plug it into our factored form or the original. So if I say f of 4, if I plug it into the factored form, it's going to be 4 plus 2 over 4 minus 3. So that gives me 6 over 1. So when I plug in 4, I go up to 6. So it's going to be in this general area up here, and there's where our boomerangs exist. So if it makes it easier for you, you can do it that way. You can do every single problem like that. Factor, 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 factor. See if there's a hole. If there is, cross it out, be done with it, and then move along. If you don't want to do it that way, that's fine. Just when you identify the hole, you have to go back and cross off the extra parts that don't work into your graph. Okay, all right. Good luck tomorrow. If you guys need anything, email me.